This week we're going to pretty much finish up all the stuff that you really need to know to do the projects, and also all the stuff all the really hard technical content that I expect you to know, and we might test you on or involve in the problem sets. So today we're going to talk about GUI components, graphic user interface components, also known as widgets. Tomorrow we're going to talk about threads and multi-threaded programming. That's probably the most difficult lecture of the week. The next day, Thursday, we're going to talk about networking, how to connect to the internet. And Friday, I'm going to talk about various aspects of how to do group program or group project development, how you would do it if you were, had a job as a developer or project manager in industry. And we'll also talk about some tools which you may or may not find useful for organizing group projects. So it's sort of a cultural one. Next Monday, I think I want to finish up a bunch of miscellaneous Java topics, which you might find useful or that we've skipped over. And then the rest of the lectures will be mainly on cultural issues, which I don't expect you to be able to use in this course, but nonetheless, it will be good to at least have heard of before and to know something about. So we'll do a lecture on Java and the internet, where we'll talk about applets, we'll talk about servlets, we'll talk about Java server pages. We'll do one on C and C++. We'll do one on binary components, the Java instance of those being Java Beans and Enterprise Java Beans, but we'll try and touch on ActiveX and Corba and all that sort of thing. So just stuff that is good to know, at least so you can go in and talk about it and make believe you know about it without actually getting into too much details. Okay. Today's topic is graphic user interface components. Where we left the previous lecture, we were able to, at the end of the week, we were able to draw frames on the screen and move them around and stuff and draw graphics in them. We were also able to catch mouse and keyboard events and react to them and change the screen and redraw the screen. And in fact, that's probably all the capability we really need to do a full graphic interface. Given that we want to do a lot of work, we could build the whole interface associated with this thing just by catching various mouse events and highlighting and redrawing and doing things. That's very tedious, and if you do it for a while, you find out you do the whole thing, you do many things over and over and over again. So when people built these sorts of interfaces and discovered this, they gradually packaged the common functionality into sets of library routines, which are commonly called widgets or sometimes GUI components, though components also sometimes implies other capabilities as well. And these are things that can be very convenient to reuse, like buttons, menus, dialog boxes, and various types of data display, like in trees and tables and lists, text input and editing. So basically, you're just given a collection of these and a big library of different widgets that you can use, and an even bigger amount of documentation to read about these libraries and hook them up. And they're remarkably convenient. The other advantage of using these libraries of components, besides programmer ease, is it takes a burden off of the user. If everybody did their own user interface from scratch, catching raw mouse events, everybody's user interface would more or less be different. On the other hand, if you use standard components in the library and organize them in standard ways, the ways the system wants to be used, you come up with something with very similar look and feel all across applications, which is a great easing or time intellectual saver for the user, because you can pretty much pull up a random application and you can see all the components, and you know pretty much what you're supposed to do in each of the components. If you see something that's like a button, you click on it. If you see a text entry window, you type some text there. And you can pull down menus and the like. And so it really makes things easier for the user because everything works the same way everywhere. And since the last thing any user ever does is read the manual for any particular piece of software, it's nice to have pieces of software that are kind of self-instructive on how to use things. So there's no new technology, really, that we're going to learn in widgets. It's mostly just a massive detail that you have to gradually get to look up and learn to love. So today is more or less going to be a tour of some of the widgets and how they work and how to hook them up. And you're on your own. The book goes through a lot more, but still only scratches the surface. And there's much more information in either kind of manuals associated entirely with GUIs. There's a 3-inch thick Java Swing manual that just goes through some of the GUI components. And there's, of course, the online doc, which is always useful. So what are the main problems with using widgets? You want to know how to instantiate them, how to build one in the first place and hook them into your window hierarchy, how to catch what events they send, and how to catch events, and how to interact with the underlying data. So you want to know how to transfer data into and out of them, especially as the widgets get more and more sophisticated. There's more and more data you have to transfer in and out. And finally, you need to know how to arrange them in attractive ways on the screen. This last topic, which goes under the topic of layout, the book talks a lot about, and we're going to gloss over today. And I think we're going to pick that up next Monday when we cover miscellaneous things, since layout is a whole deal in its own, and it'll just be a distraction from how to use the basic widgets. Another thing we won't talk about is the whole issue of design. What makes a good graphic user interface design? What makes a bad graphic user interface design? This is a whole field in itself with many books written on it. There are journals, there are conferences. It often goes under the heading of computer-human interaction. There's a SIGCHI conference devoted entirely to this. There are people who have tests for user interfaces where they sit people down and give them a task and count how long it takes them to click and how many buttons they have to click, and compare metrics on user interfaces like this. We're going to ignore all that and assume you know what you want to build and worry about just how to build it. Now, the Java Swing components that we're going to talk about today have embraced the model view controller design pattern very much in the organization. So there's an underlying computational model which holds the data that's involved in these widgets. There is then a kind of view mechanism. All of this is mostly hidden from you. There's a view which is what organizes that on the screen and worries about how to display it. Okay, and you can manipulate how to display the various things without affecting the model. And then there's the controller, which updates the model from commands from the screen and sends actions to the user telling you something interesting has happened. So most of what you will do to interact with GUIs is either catch events, or widgets is to catch events and process them like we do to the mouse, or once you've got an event, interact directly with the model. As we'll see at the end, we'll talk about the table widget. Pretty much all of your interaction is going to be through the model, and you won't really interact with the events at all. So let's start with the simplest or most straightforward widget, which is a button, and that inherits from the class JButton. The model for a button is particularly simple. It just has a string associated with it that's a command, and then another string associated with it, or string or icon, which is the label that is shown on the surface of the button when it's drawn. by default, you only have to set the label and the command will get propagated for that. So let's look at how we do our various steps. Instantiation and I'll call it incorporation into the hierarchy, and then events, and not very much of this of interest in the button case, since there's not much data to transfer, but that's our third case. Buttons are particularly simple in that they work very much the way you would expect them to work. Let me pop up rather than trying to write a bunch of code. Let's try this approach. To make a new button, you just make a new button. All right, so you have a constructor on buttons. So you do new JButton. You give it a string, which is the string you want on the button. And it makes a new button and puts it in this variable. It doesn't show it yet or do anything. You have to link it in. Much the way we linked in JPanels to frames using the add command, we link in buttons and other components into our window hierarchy. So here I'm going to link it into the my panel. If you recall my application that we've used the past couple lectures, we've had a frame, and the frame has in it a single panel. And since I'm not going to try and fool around with layout today, I'm just going to whack all of my components into that one panel. So I'm adding the button toggle to the panel. Then I need a listener. So this pretty much works the same as our mouse listener. I make a class which instead of mouse handler I call button handler. And the event type that you get from most widgets that have simple interaction is called an action event. And an action event is produced by buttons and their relatives. It's produced by menus. It's produced by text windows. An action event only has one method, or action event is the name of the event. As we decided or learned last week, each event type has a corresponding listener type, which is the interface, which tells you which methods that the Windows system will handle associated with that event. And the listener for action event is action listener, and it has one method on it, which is action performed. And that gets passed, and when it's called from the Windows system, it gets called with an action event as its one argument, which is the event object that got generated. So here's a very simple handler. So I implement action listener interface, and I implement this routine action performed, which is what I'm supposed to do. And right now, all it does is print out toggle pressed. So now I've got everything hooked up, pretty much. I've created my widget. I've hooked it into an existing panel. I've made a listener, and then down here I add my action listener. You add action listener rather than add mouse listener to the button, because the button is the thing that produces the event. I have to add the listener to the button. Now, a toggle button on my Hello World thing. And when I click it, it calls that and prints toggle pressed. Pretty cool. Not much work, and we got a button. Just like the mouse, with the mouse, you want to do more in your handlers than just print out stuff. So you need to interact with application data somehow. And this is one of the main problems that one runs into in using these components or widgets. You have to link the actions on the components themselves to the application data. And so that gets into some ugly sharing. You have to organize the sharing And the structure so that only the communication between things is sufficient, but not so great as to become ugly and unmanageable. So let's see. Let's steal some code from our mouse example the other day. Here's a good piece. Okay, and let me put it there and then just move it around. This is our friendly piece of code that toggled the color that we just stole from our mouse handler, and let's pop that in there. Current is the color used by the panel to paint the and now it's not working. Oh, I know, I have to repaint. Bink. Bink. Return type required. Oh, thank you. Thank you. One of the dangers of cut and paste. All right, so this looks now very much like our mouse app. When I click that, it toggles. But unlike the mouse app, when I click every place else, it doesn't toggle. All right, well, that worked well. So I'm going to add another button.
So you said the challenge is making your components interact with the data in the application itself?
To do that, to get it to do that and do it gracefully. So that, as you'll see, as we add things, things start to get a little more complicated and a little more hairy and a little uglier. And eventually, you get the feeling you're losing control. So you need to go to a different level of organization. Right now, we've got all of our handlers in this button handler here. And that'll serve us for a little while. So I've made a green button, which I'm going to make just set the color to green. And I've added it and linked it in. And now I need a listener for it. Now I could do one of two things. I could make a green button handler, which implements action listener, which does the green thing and hook it up to here. Okay, that means I have two action listeners, respond one action listener for each button. That's one choice, and we know how to do that. Another choice is to try and reuse our current handler to do both, to handle both buttons. And let's try and do that. I'm not saying that it's always the best thing to do, but we know how to do the other thing. One piece of information that we can get from the action event is the source of the action. It basically will give us back the object that caused the event, and we can compare against it. So I can say if E dot equals, I think I have to do E dot get source. If that equals, maybe I can even get away with this, toggle. I want to do the toggle stuff.
Can you even open parent before toggle, after toggle?
Toggle is just a this variable. So I'm just comparing this against that value. And we'll come down here. So if it's green, I want to do the green thing, which will just be to set the color to be green. And just to be good, I'll do an else if instead of just an elf. Does that look good? Do we have any chance that that's going to work? And now, of course, I still have to add a listener to green. And instead of adding a new listener, I'm just going to reuse my old one, because now this listener object handles both. As he crosses his fingers. And now I have 2 buttons. Cool. And that one toggles. And that one sets a green. And that one toggles. And that one sets a green. It's a nice lime green. OK.
If you don't tell the buttons where to go, they just go to the top.
Yes, that's the whole issue of layout, how to get the buttons to go where you want them to go. And as I say, I think I'll postpone that till next Monday because it's incredibly tedious and it takes an enormous amount of time to get it right because you have to try stuff, then you have to look at it, and then you say, this doesn't look quite right. You also have to deal with the fact that you want it to work well in different sizes if you're going to be elegant and resize things properly. And then a lot of times you just give up on that and say, OK, I'm going to make it for one size, lay things out, and just lay them out in a fixed place. But yeah. But as I add more things, you'll see that that it starts to get less good. Yeah.
Get source tells you which button is being pressed.
Get source tells you which widget the event came from. So you get an event, right? And then you get this action event, which calls action performed and gets passed in with the event. And on this event is information about which widget. So it doesn't have to be a button. It could be any sort of widget, as we'll see. So let's add another widget. Another simple, very useful one is text input. Okay, this lets you type in a line of text and use it in your application. There's 2 versions of that. One is called text field, JText field, and one of them is called JText area. JText field is what you use if you just want to collect a single field of data. It gives you something like this that will accept a single line. Text area is if you want something bigger. The user's typing in a paragraph or an email message or something. And there's ways of associating scroll bars with this as well, which make it convenient for larger things. J text area. Field. Okay. Now the model for both of these things is essentially the text that you've typed in, the text that's in the box. And so you can interact with these things by querying the model. You can say, get me the text that's in there, or in the case of JText area, there's lots of different substrings operations you can do. Give me the text past this point. Give me any substring of the text. That's interesting. Now, Java gets even a little more sophisticated than that in terms of just thinking of it as text. It actually gives you something called a document model, which is an object associated with this text that lets you do, that kind of canonicalizes how you deal with text documents and has not only some routines associated for manipulating documents, but there are also events associated with the document themselves. Like when the user does some edits and updates, the document is the thing that's going to send you events. And these things get clustered so that some things like corrections and the like don't get counted. Some things, or just cursor movement characters, would not get counted and not generate events, but any actual changes to the text would generate various types of insertion events or deletion events or other change events on the document. So you could run your interaction on the document events if you want to do something very sophisticated. Now, and every time the user changed the text there, The book gives an example of updating the clock based on the user typing in a time, and so every time the user types in a character, you just change the look of the clock face. Document interfaces are actually this is an instance of a very general thing. You'll see document interfaces all over the place these days to kind of canonicalize and unify all the different ways of looking at documents. And documents are now thought of in the very large sense or very general sense with the coming of XML. Associated with XML, there is a document interface called, actually there's two, one of them called the Document Object Model, often called DOM. This gives you a bunch of routines for looking at an arbitrary document represented in XML. Java actually not only implements the official W3C DOM standard, but they also have a JDOM of their own, which is kind of a simplified version for looking at documents. But because we're not going to be too tedious, are not going to use the document events and document interface to deal with our text field. We're just going to use our old friend, the action event. And so what action does a text field send? Basically, it sends an action every time the user hits enter in the field. So every time the user types something and then hits enter, being the carriage return key, the text field will send us an action performed or a action event and a call action performed in our listener if we provided one. And once we've got that event, we can then go get our data. So let's add in one of these into our system. Let's see if I can swipe something good from the lecture notes rather than typing it by hand. Well, maybe I can't. Let's see. Swipe. Oh, no. On Windows I would, but okay, so rather than, as I could make a text action handler that also implements this routine, but since I'm going to be lazy here, I'm going to share our one action listener between our two buttons and our text field. Again, this may or may not be excellent programming practice, but it's not clear it isn't either. You have to make the decisions on how to do this how you want to organize it based on the overall structure of your program and how it looks. The constructor for text field takes a count, which is the number of characters. It can also take a string, which is the default thing we want to put in there. We're going to start it empty. So that's all we have to do to make it. Oh, right. JText field, text. We just add our good old listener there. We add them. And the order in which you add them, this is another layout issue, the order in which you do these adds is going to affect the order in which they show up. So did I actually do everything? I've created one. I've added it into our window hierarchy. I've whacked it into the panel. I've added an action listener. And what is my action listener going to do? I see if the source is text. I'm going to call the getText method on the JText field. GetText is an accessor method on the widget, and it's essentially an accessor on the model, which is going to give me the current text that's displayed in the window as a string. And if it's not null, if there's something in there, I'm going to put that into this string variable called message, which is what our paint method, where's our paint component method here? Don't get dizzy. Is using to call for drawstring. So let's run this guy. Ta-da. So now we have our button, toggle button, our green button, and our text field. So we can write in some text, and I claimed that when I hit enter, that action event would happen, and that gets called, and it updates the string that we are displaying. And now I can toggle that string and make it green. And
The text field also do the same as enter, or is it only enter?
The which?
The text field.
if I click in it, did you say? Or?
Yeah, is enter the only thing that constitutes an action?
I believe so. Let's put it back to, there may be other keys that are mapped essentially to enter, but for example, clicking doesn't do any good, nor does moving out of the field. And notice I have all sorts of edit capabilities in here. I can backspace. Control characters do not work in Emacs fashion. They seem to work in Windows fashion. If I double click, it'll select Word. I can then replace all of this without the program, my program, having to do a bit of work.
You hit toggle, will it take the text, it would change it?
It just takes that text. Hasn't until I push enter. All I've got here, all I'm doing is updating the model in the widget. Those stuff in the widget has not made it out of the widget into my application. The thing that makes it do that is my piece of code in the action listener, which calls getText. So if I go there and hit enter, now I've got hold for, whatever that means.
If you submit an empty text box, does that become a null string or an empty?
That's a good question, and it could go either way.
You test for it, though.
I test for it, but we'll see what happens if I just do that. Nope, it apparently returns an empty string, because I test for null, and the fact that it took it means it must be an empty string.
Can it take?
I believe you can just keep typing and typing and typing in this thing. The size I put in really refers to the size of the window it's going to show, the kind of preferred size of this. Again, this comes down to layout issues.
You can't limit, though. You can't put a, I mean, you know, I've seen where it's
Yes, I believe to do that, you would have to be more sophisticated and either catch document events so that every time the user typed a character, after a while you would stop listening to them, or you would have to, in the action event, you could test the length of the string and basically beep or something if it was too long and not accept it until it was the right size.
If you resize the window, do the buttons move?
Yes, this is a layout sort of deal. Goes back to the layout issue. But if I resize the window, notice this guy jumps up to, and then it goes down, and then we do that, and then they just get really squeezed. I guess I like that. That is the property of this particular layout approach that's enforced by default by JPanel. There's a half dozen strategies that you can use, or you can just kind of glue them down in absolute XY positions so they don't move on you.
You like do things like center or
Center?
yeah, something like that. So you wanted to center the text, whatever the message is, however long it is, you wanted it centered.
With work, yes. With a surprising amount of work, you could do that. All right. So, text input fields. Any questions?
These the action events, they seem to be specified by default for different actions for different kinds of objects. So that, I mean, we're safe in assuming that it's a left click for a button and a return for a
Right.
text field and so on.
Right, and you just have to go to the documentation to tell you what is going to generate an action event, if anything. We'll see some things which won't generate action events. All right, so there's piles of these things. Buttons, in particular, have a whole mess of cousins, which all work pretty much the same. There are radio boxes, which allow you to check some set of options and then hit a enter and get an action performed event. There are check boxes, or maybe it's the reverse. Check boxes let you check multiple things. Radio boxes let you give you a bunch of options and let you check exactly one. What other kind? There are list boxes which have a pull-down list where you get a list of options and you click on one of the options and that gives you the action perform event. So they all pretty much work the same as buttons. They just give you different look and feel. And they're all pretty much set up the same way. So we won't really go over those. The next thing I want to do is menus, which look and kind of are set up very different than buttons. But ultimately, if you think about what a menu does, you do a bunch of pull downs, you do a bunch of pull downs, you do a bunch of pull downs. Finally, you click on something. And so at the very lowest level, clicking on a menu item is semantically equivalent to pressing a button. Menus are just a fancy way of hiding big collections of buttons. So you will see that to handle a menu selection, we just handle it exactly the same as we did with our button. We use our friendly neighborhood action event and just our action performed method. As a matter of fact, I think I'm going to try and reuse exactly the one we have here. Our picture, our frame. We have our title bar up here, which we don't have any control over. And then we have our panel. The menu actually gets placed into the frame, usually in a menu bar on top. And you get a menu tag which is listed across the top. And then when you click on this, it opens up and gives you a bunch of choices. And some of these can have submenus that will open up and give you another bunch of choices. So we've got a bunch of things to build. We have to build our menu bar. Okay. And then we have to build a bunch of menus. And we have to add the menus to the menu bar. Okay. And we have to add the menu bar to the J-frame. And finally, we have to add each one of these guys. This points to kind of this whole thing. Each one of these things, which is a menu item. All right, we have to link that into the menu. And then we have to link into this through our action listener. So that's the process. It looks tedious, and it is kind of tedious. On the other hand, it's not conceptually hard. If I was lucky, I would even have something. I have something called menu test, which maybe I can swipe from. Or let's see if this works. All right, let's start from the beginning down here. I make my frame, my panel, my usual stuff. Now, do I have a menu bar? Okay, so I set all this up in my panel. So first thing I do is I make a menu bar, and I add it to the frame. All right. Now, how did I get the frame? I'm in my panel descriptor, and I need I'm in my panel constructor, my panel. I apologize for moving around so much, but I need to get a hold of the frame, which I didn't have access to before in the my panel class. And this is something you'll find you have to do occasionally, is to pass in the frame into the constructor. Okay, so And occasionally you have to even store it as an instance variable in the panel. So each kind of child window sometimes needs to know what frame it's in or what panel it's in so it can do higher level commands like add stuff here. So I pass in the frame and I make a menu bar and then I just add it. All right? So then I'm going to make a menu. All of this is pretty straightforward. The string you give the constructor to menu is the string you want on your menu bar. Let's make a couple more of these just for fun. Let's make dmenu. And let's give it the name Dave. All right. Now I need to make some menu items. And in this program, I actually make them someplace. I'm sorry. I define them up there. But rather than using a constructor to make JMenuItem and then do an add, okay, you can get there's a convenience routine on menu, JMenu, where you can add a string. What this will do is create a menu item for you, create a JMenuItem for you, associate it with that string, and then return to you that JMenuItem. So this is actually performing both the linking in and the constructor. That's why I'm assigning it to toggle, which is now, in this application, not a JButton, but a JMenuItem. And so I can also do things like add separator, which just adds a little line across your menu to make it look kind of cool. And then I can add make and add another menu item called green. And I have to add these listeners in as before, exactly the same as we did with buttons. And indeed, I'm going to use exactly the same listener code. I'm just going to swipe it. So what I'm doing is, instead of having two buttons, toggle and green, that do those actions, what I'm going to do is associate those actions with menu items now. And since menu items, when you select them, are invoked through exactly the same mechanism, they send an action event, which is picked up by the action listener and called action performed. I actually use exactly the same code. The only difference is that green and text, instead of being defined as JButtons, like they were in our previous application, are defined as JMenuItems, and the whole setup is different. Instead of making new JButtons, I'm making a menu bar and then menu and then add, and hooking them all together that way. So,
How come you don't add the menu bar under your frame class instead of?
oh, I do right here. Set JMenuBar.
That's on my panel, right? That's on the my.
It's under my panel, but notice in the constructor to my panel, I'm passing in as an argument my JFrame, and if
So why don't you just do it in my frame?
I could do that, but then then I have a sharing problem, because these commands here need to have access to the menu bar, right? So if I want to do this, move this thing out, I've then got to move this, make it an instance variable. Okay, so once you start to move things, it propagates. That's certainly a legitimate thing to do. I just decided to do it this way. But there's no reason to think that one way is intrinsically better than the other. It boils down to, all right, so here we have our widget test program again, but the buttons have gone away, and instead I have two things on the menu bar. Dave, I didn't put any items under, so it doesn't really do anything. Colors, I put two things under. Notice we have toggle. We have this bar here, which is not there by default, but it's that add separator that I added. It gives you that nice bar. And then green. And now selecting these menu items has exactly the same effect as pushing the buttons, because we're using the same action handler, but it's just a totally different mechanism of invoking them. And You can put in text strings, and just everything works the same as before.
If we wanted to set hotkeys, so for example, if you hit C, then it would
Right.
go to the color drop down, or D to go to the date drop down, or something like that.
Right. This gets us into the topic of kind of action classes. One way to do these action handlers is to implement the action listener interface, okay? And then just connect these things up. Now, you notice we did a lot of reusing here, and often you'd like to get both the buttons and some hotkeys and the colors to do the same thing. So you can actually create a object called, it inherits from abstract action rather than implements listener. Okay? Abstract action is something that does implement listener, so it has the action performed thing, but it also has a bunch of other classes that Java, or other methods that Java knows how to use that are particular to the button menu sort of deal. In particular, you can set the text string and the command and the display icon. So you could make one of these objects, use it as an argument to the constructor for a menu item or a button, or I believe you can invoke it from a key press. So you can have multiple events happening, or multiple controls all having the same event invoked. I think that would be the cleanest thing to add the hotkeys. I don't know whether there is a direct way to add hotkeys to menu items or not. There may be. But then you would have to wonder what event, since action event is already used up, you would have to have a way to tie in a particular key, to a particular menu item to invoke action event.
Action events takes different actions and does different. I mean, if you hit a return, that works differently than if you do a click.
Well, the trouble with all these things is you basically get one piece of information per widget in this case, which is just that an action happened. And what the action is defined to be varies. The text widget, the action is defined to be return. On button, it's defined to be a click. On menu, it's defined to be pull, pull, and then lift up. Okay? I think it is certainly conceivable that you could also define, add a key so that an action was on a menu item was defined to be either, say, you press the K key or you select it. To be honest, I have never done that in Java and don't know the mechanism. It certainly works that way in Windows, but I cannot say in Java. All right. Paint component is actually the same one we used all along. We call super.paint component, which calls the paint component of our parent class, in this case JPanel, and all that does is clean up the old thing and give us a background. We then call setColor of current, which whatever color that's in that current variable, which is the thing we're fooling around with in the buttons, we set it, our current drawing color to that. Then we just call this drawString routine, which draws the message variable, which is the thing we're putting the output of the text widget. When we do a getText, we whack it into this message variable. And then we're just saying draw the string at points 50, 100, starting at pixel 50 down and 100 over. No, it's 50 over and 100 down, sorry.
Okay, so you put these in a class because these are all the methods that...
This is the paint component method of our panel. Okay, all this is inheriting is on my panel, which extends in JPanel. Okay, so panels have a paint component method, which is essentially another interface, but it's kind of called behind the scenes. It's another one of these callbacks from the Windows system. And so anytime anything interesting happens, like you uncover a window, or whenever the application calls the repaint method, all that does is cause paint component to get called. So all repaint does is cause the window system to call paint component.
So calling paint component, calling super dot paint component doesn't induce flicker because of it refills the background?
It doesn't, because Swing is careful to double buffer behind the scenes. So basically it will build up a new image and then pop it into the frame all at once.
That's different from, is that different from before? Or
I believe it's different between the older versions of AWT. You did have to worry about flicker, either do your double buffering yourself or just be very careful about how you drew, like erase all your lines instead of clearing everything. But they've made it a little easier with this, which you must admit is much nicer. I don't know whether you've ever tried to do erase the old thing line by line and redraw it. All right, the next thing we're going to talk about is dialog boxes, getting more and more complex. Dialog boxes are different than the things we've talked about so far in a number of ways, okay? One way, let's do some art. One way is they pop up a separate frame with its own little toolbar here with the close and title and all that. But this frame isn't around all the time. It's invoked by some action over here, which pops this up. But then this is just a normal frame, just like this, and it can have components in it, our little buttons and the like, and works the same as this. There's two types of dialogues. One is called modal, which is most of them. The other is called modeless. Modal dialogues have the property that when you pop them up, they block any input to the main application until you've gotten rid of them. So they basically grab the focus of the application and make sure you only talk to the dialog box. And then when you finish with the dialog and you close it, it vanishes. And then control goes back to the application. Those are the majority of useful ones and the easiest ones conceptually to deal with. Modeless dialog boxes are dialog boxes that you throw up, and then both of these kind of continue on. There's a single application, but things are going on here, things are going on here. You have to make sure they interact cleanly. Quite a bit more complicated. We won't talk about those. Java gives you a simple facility for popping up several canonical types of boxes which are useful, which are methods on, I think it's J, option pane. There are a number of static methods to pop up certain types of boxes, the most common one being a message box, which just pops up something that displays your message with an OK button, and that just sits there until the user hits OK. This is a nice way to do warnings, or do you really want me to delete all your files, that sort of thing. You usually pop up a message box to verify things. Those are very easy to do. You just call a variety. There's 4 routines that you can call that gives you various flavors of those. We won't deal with these. We'll talk about more complicated dialog boxes where what we're going to try and do is move our toggle and green buttons over to a dialog box instead of having them over here. And the main problem we're going to face, though it's not a big deal, is how to get data across here. And again, this isn't a big deal. You just have to create some objects, create accessors, and keep everything straight. So let me pop up some code rather than sketch it out on the board. this is the class that's going to represent our dialog thing. And rather than inherit from JFrame, dialogs inherit from JDialog. And JDialog has some control or routines associated with it that control its appearance, one of which is show, pretty much the same show routine that we had in JFrame, which basically pops up the window and throws us into the event loop for this frame. We have hide and dispose. Okay, both of these pop down the window and make it go away, and they also cause the program to return from show. So if your main program calls dialog.show, it'll pop up the window, and it'll be blocked in show until the dialog returns. I mean, it'll still handle events from in the dialog, but it won't do anything in the rest of the program. That's how it kind of locks out the rest of the program. So hide or dispose cause the dialog to return. Now, the book implies that dispose kind of cleans up the dialog as well. It wrecks the dialog. Hide is supposed to just make it less visible, and so you can reuse it later without making a new one. After extensive trying things, I found that that does not work, and that some of the examples in the book, I suspect, will not work. So I would recommend making a new dialog. Every time you want to pop up a dialog, make a new one every time. I found that everything works the first time you call the dialog, and then you try and pop it up again, and strange and not necessarily good things happen, like you can't see it.
Can you not click on the parent window when the dialog is still up? Does it lock it out in that sense?
It locks it out in that sense. It does not, since what you're really in is the event loop for this frame, it's just not going to process events for that one. If you want to do both, you have to do a modeless dialog. So first, let's look at our dialog class. The main dialog class, this corresponds to our myFrame class in our major example. But instead of making a myFrame, we make a myDialog and extend myDialog. And all we're really going to do is pretty much rebuild the structure we had before. But we do the set size, we do the set default close operation. Notice instead of exit on close, I'm setting it to dispose on close, which means instead of exiting, shutting down my whole application, it will just call this dispose method and get rid of the menu window. Note that there's several ways you can exit a dialog. For example, one of these buttons could exit by calling explicitly dispose, or the user could hit the close window button, and that's supposed to behave properly. So you really have to check all the ways the user can exit the dialog and make them work the way you'd like. So we do the same thing. Instead of making a My panel, we have to make a panel. We get the content pane. We add the panel just like we were setting up a normal frame. And one thing important we have to do here is call the super constructor, which calls the constructor on JDialog. And this has 3 arguments, one of which is the parent, which is the main frame of the application, which I'm passing in. The second is our title string, which we always want to display. This third one tells you whether it's modal or not. And I'm going to make that true because I want it to be modal. All right. Now we have dialog panel, which is the analog in our dialog box to our panel. And we're going to have a color, which we're going to initialize to black. Actually, I'm going to initialize it to red. And I'm going to add our buttons, our good old friend buttons, toggle and green, and another button I'm going to call OK, which means that we're ready to return from the dialog. So toggle and green are just going to affect that, and I'm going to do them a lot of times, and then we're going to return only when we hit OK. So here is the button handler. Looks just like the button handler we had before. It is the button handler we had before, except the OK button is going to call hide on our dialog. Okay, when we create the dialog, when we create a dialog panel, we're going to create a dialog in an instance variable so we can get a hold of it. So here's where we're going to keep so dialog panel, we pass this in. We add our listeners just before we make up this whole thing. So my dialog panel, which has the color, I'm going to make a get current, which just returns current. And then the thing, because the thing I have really in my other application is this dialog frame, I have to make an accessor here, which just gets the thing out of the dialog panel. Okay, so if you look at the way these things are connected, you have the dialog frame, then you have the dialog panel inside, and inside that you have the buttons, and the color is living on the dialog panel, so I need to just have a way to pass it all out. So now I've created I've set up my classes for the dialog, I've defined the dialog, but I haven't done anything with it yet. So for here we need, okay, this is our familiar program that makes a frame, and then a frame, it makes a panel, and I'm putting this on a menu. I'm just pretty much copying the menu code from my previous application, but instead of having the menu code have a toggle and a green, I'm having a menu item called pop-up. Okay, I could have a button called pop-up, just the same, and this is the handler for that, and all it's going to do is do this dialog.show. Okay, I'll show you. It's going to actually here. It creates a new my dialog. Okay, it just creates a new my dialog, and so that's the class we defined before that has all our dialog stuff in it. We do a dialog.show, which is going to pop it up, and start handling events from it. So then I'm going to be clicking around in the dialog. And then when it's done, I need to get the data out. So I just do current equals dialog.getCurrent is the routine I built to get the color out of the dialog. And now I just whack it into my color, and then I do a repaint. So this is the world's most elaborate way to do a color button. All right. Very good. I hope this works. All right, so here we have our health-friendly Hello World application. Now, instead of those red and green, I have pop-up dialog. So I come over here, and I've got nothing happening here, except internally, it's toggling the color. If I was cool, I would put a little display here to tell you what the color was. But the last thing I'm going to type on is green. And now I'm going to type OK, which in my handler calls dispose, which returns out of the dialog loop, brings us back here. So if all is right with the world, this should turn green when I hit dispose. I think that's worth some applause. And I can do it again because I'm making a new one. And let's try toggling. And can anybody guess what color it's going to be?
Red.
I bet blue. Because when we popped it up, the default color in the dialog box was red. I hit toggle once, which switches to blue. Then I pull back blue.
So if you pop it up now, you won't be able to click in dialog test.
Right.
Now, if you were to click green
Yeah.
and then
Toggle, it should be red. Yes. So My theory is, though I'm not sure about this, that I should not be able to type into that guy as well. Yes, it's just beeping like mad and complaining to me.
Can you click on email?
Oh yeah, these are different applications. So any other application should work. But these are both associated with my,
So you couldn't close the main one.
But you can still get focus to the main one, even though you can't.
yes. But it's not going to accept any widget events from it. It will probably close the window for me. Yeah?
You used dialog.hide when you get rid of the window.
Uh-huh.
If you would use dialog.dispose, would you not be able to return the current value as current color? Is that why you use hide?
You know, that's a very good question. And I actually do not know the answer to that. I thought I was using hide because I originally wanted to reuse the whole dialogue, but it did not seem to work, no matter how hard I tried, even though it seemed to work in the book. So as you see here, I'm creating a new one. I am not sure whether the dispose just destroys the view and the controller, or whether it destroys the actual object as well. I would suspect it does not, because that will hold back that really is just a data structure linked into Java. So it can't really call the garbage collector on that. Otherwise, you've got this pointer that, refers to something that's garbage collected. So I think it's just destroying the Windows system, or disposing of the Windows system resources that are responsible for drawing that. I have not tried it, but I believe that's the only logical way it could work. All right, one more thing, and then we're done. I want to try something completely different, which is a table widget. There are a number of really cool widgets that are talked about in the second book, which are there for displaying data of various times. There's a tree widget, which gives you a nice expandable, contractible tree display of data, and all the expansion to the nodes and contraction in the nodes and all that happen automatically for you. You don't have to do any of that work. The table widget gives you, as would imply, a tabular display of a number of columns and a number of rows. So it basically gives you something that looks like an Excel spreadsheet, and you get to put data in the rows, and it gives you labels for the columns, and the display worries about how to display things and moving the columns around. And this widget has a very complicated model. And in fact, all we are going to do to interact with it is talk to the model. We're not going to handle any actions at all here. Is that true? Yes, it is true. We're not going to handle any actions in this example. What we're going to do is simply make up the model, which, of course, conforms to an interface. And then we're going to give the model to our table, and then everything is just going to happen very nicely. This is just a nice structure, so it's worth. The main component we want to give it to is JTable, and the model inherits from interfaces for which there's an abstract class that implements part of it in the usual Java way. So the thing ultimately we want to deal with is something called abstract table model, which implements the interface called, I believe, table model, which is an interface. And so abstract table model is an instantiation of almost all of it. And the routines that you have to add are basically routines that describe, okay, the model is basically this. An array of cells. So we have a number of rows. We have a number of columns. Okay, and then we have a data value in each cell. And each of the columns has names. And here's the cool thing. If you think about how to describe this data structure, you can come up with a very small number of of methods that describe it from the outside as a black box, and that's pretty much the interface that you have to implement. So, for example, there's get the number of columns, get the number of rows, okay? Get the names of column C, it just returns a string, and then get the value at each one of these things, all right? And this value, you can actually have stored this in a two-dimensional array, or you can just compute the whole thing on the fly. There's also set value at, which is what the model or the controller is going to call on the model when you try and edit a cell. If you set a cell that you can edit it, when you finish editing it, the controller is going to call your set value at routine, and you use that to update the cell. And there's also a routine that queries each cell and tells you whether it's editable or not. So to look at my implementation, I've made something that is going to have 2 columns, and I think you get to pass in the number of rows, yes. So my constructor, it has 2 columns and an indefinite number of rows. The columns are named day and hours. They're kind of, my consultant billing strategy. So you have 31 days. And the hours is initialized, we're going to store a data array, which is initialized to some random number between 0 and 8. I really don't bill by that mechanism, but it's easy to do. So we make up a bunch of random numbers and store them in an array. So that's our constructor. Now our get column count and row count just returns the sizes. The names are pretty straightforward. They just return from there. Get value at, if C is equal to 0 for the first column is going to be my day, I just return whatever the row integer is. So I'm just going to label the first column as just going to be the row number, starting from 0, going to whatever. And if it's the second column, if C is equal to 1, I'm going to return whatever value is in my hours array. For set value, I'm not going to allow the first column to be set. So only if C is greater than 0 am I going to return true on editable. Otherwise, I return false. And if it's editable and I get a value, I'm just going to set my hours here. So, and all I'm going to do is, for main, is create a frame and show it. So now I've built a table model. How do I build a table? And it's just amazingly easy. Okay, first I create a table model, and I'm doing it with 31 rows. I pass in 31. Then I make a table based on the model. Then I get the content pane of my frame, like I always do. And because I like scrolling, I want to add scrolling to this thing. I'm going to make something called a JScroll pane, which just gives you something that adds a scroll bar to whatever you give it as a constructor. So I'm taking my table over here, and I'm creating a new JScroll pane with that as its argument. So that's going to give me my table with the scroll bar on it, and I don't have to do any work besides that to do scrolling. And then I'm going to give the scroller to the content pane. So I've just made this big chain of thing from table model to table to scroll pane to content pane to frame. Complicated conceptually, but each one is just a line of code. And if you notice, you start to have to include more and more and more stuff up here. Like here I'm including swing, swing.table, AWT, AWT event, and geometry. I probably don't need geometry here since I'm not drawing any rectangles. And this pops up a table. Notice I have a scroll bar. It goes from 0 to 30. I have 31 entries. The scroll bar, I didn't have to do any work. I can shrink and grow it, and if I grow it big enough, the scroll bar will disappear. It only appears when I need it. I have days numbered. I have an hours column that's random. It will let you, for some reason, switch the columns. Okay. This is totally something done in the view. In the model, the model column 0 conceptually is still days. Column 1 conceptually is still hours. I haven't switched them in the model. It's just that it's displaying column 1 here and column 0 here now. Let's put them back. It will do, I believe, other things for you. I think you can get them to sort. Now, I've made this guy not editable, but I've made this guy editable. So I can change him to 40. I'll say I've had a very busy day. 620. And these things stick. You know, they're not only remembered by the view, but what's happened is the view has called the controller. When I finish editing a cell, it calls my setValueAt method with this new value, and I've updated that in the array. And so this is really just a reflection of what's in that model at any given time. Really shows the power of this model view architecture, since they supply the view and an interface to the model, okay? And they do all the display work, and all you have to do is the model work. Now, you can add a whole mess of technology onto this. The stuff I have in here are basically strings and numbers, but the cells of a table can be icons. They can be any object type. Okay? Yes?
What happens, your model has an array of integers. What happens if you try to give it a string, say?
Well, it will probably throw an exception when it tries to convert it. Yes. And actually, when you're in, when you are in the GUI system, as opposed to the console, and you throw an uncaught event, it usually, when it's in the event loop, it just prints a long printout, which runs through all the stuff. You know, these are all the methods being called when I hit that return. Eventually, somewhere here, it calls setValueAt. So all that's being popped down. Here's my setValueAt that's being called. My setValueAt tries to convert it to an integer, and here's what's failing. So, but notice it didn't quit. When it's in the event loop and you get an exception, it just prints out this and keeps going.
So you could now go back to that line and type in a valid.
Yeah.
And would
And
it do the same thing if you put in like 3.4? It would also throw an error. Or would that just truncate it?
Good question. Looks like it threw an error, yeah. So there's more technology. As I said, you can hang on to these things. You can make an arbitrary object in every cell. And how do you edit an arbitrary object? Well, it gives you a capability of heading on each cell a cell editor. The default cell editor is just this thing that lets you put in strings, and will call setValueAt with a string, and then you have to convert it to your data type. But if you have something like a picture that's not convertible to strings, you could put any kind of editor in there, which again is another object with an interface. There's also mechanisms for dealing with selection. I can select columns. I guess I have to tell it how I want to select it. By default, it seems to want to select rows or rectangles. I believe there's a way to put it into column selection mode. So I can select individual columns or individual areas. And then there's ways to get at the selection and only process the selected items. There does not seem to be a event that gets called when you've selected something. You would think a convenient action would be you select something and you want to deal with that, or you do that. I guess the reason it doesn't is there's no way to distinguish whether you're finished selecting or you have more to go. So it waits for you to first do a selection, then hit a button or pull down a menu item or something that specifies a command that you're supposed to do to those rows.
Just out of curiosity, if you're in one of the hours
Which one, or does that take it as an input?
No. It does the Excel thing. As a matter of fact, it seems to take me to the next row. I don't know whether that's because I only let these columns be editable and it skips over these. It maybe takes you to the next editable thing. But that's a theory. So again, all of that is built into the automation of the view and the controller, and each one of these things have a pile of parameters that you can set to fine-tune their behavior. That's about all I have for widgets. That's kind of a tour of the main ones, the most useful ones you would use. The book has much more on it, and as I say, there's another big book 3 inches thick on Swing itself, and then there's always the online pages. Some of the other widgets to look at that are fun are the tree widget, which lets you display, it's basically what the file browsers sort of use. The tabbed widget, which is a very handy one. It gives you that tabbed display where you click on a tab and then you get a new set of controls each time. I think people are more and more using that rather than pop-up windows to kind of have multiple dialogues and multiple views on top of each other. I like that one very much. Let's see, what other ones are there? There are sliders to let you input numerical numbers. There are progress bars that will print out, download progress, show download progress in animation. There are little spinners that let you increment and decrement numerical values. There's a whole mess of these things. There's also some built-in dialogues that are handy to call up. They're a little elaborate to use, but aside from these option pane ones that have message, there's a couple very fancy ones that do hard things. The most important one is probably the file chooser. So if you want to have the user input a file, instead of just having them type in the file name, it's nice to have that browse capability. And so the file dialog is a prepackaged unit that you can call. It'll pop up a dialog box and give the user, a tree display of the file system, the ability to go up and down, to type, to delete, to filter, all the usual sorts of things you see in these applications. And then when the user says OK, it'll just return to you a string, a file name. So semantically, it kind of works like a text input thing, but it is much more convenient for the user. There's also, I think, a built-in color selector that puts a very nice display and lets you create your own colors and select your own colors, and so you don't have to have a good feel for what RGB codes look like. So I encourage you to go to the documentation and play around with these things. You'll use a lot of them in the Problem Set 3 design project, since there'll be a need for quite a sophisticated GUI on that. And that's all. Thank you for coming. Welcome back.